So without further ado, my friend Ivan is going to do the last talk.
How much time do I have?
You have half an hour. I think Monzo 1 is out by 9, but just take your time.
Okay, let's talk about using Kubernetes. By the way, like Monzo is hiring. I applied for Monzo and they rejected my application. It was aerobic instructor. Where is Marcelo? You cannot hear me? No. Can you hear me now? No. This is the story of my life. Can you hear me now? That's how all my meetings begin. Can you hear me? let me check my microphone. So yeah, I applied for Monzo aerobic instructor. They didn't accept my application. Overqualified, they said. I'm sure it was my lycra. Like, tell me, what was the problem with me? Right. Let's talk about using Kubernetes. So people ask me about advice. I'm going to trip. So I'm going to move this a little bit. Now is when the whole thing falls down and yeah. So people ask me about in Kubernetes, how like shall I use Kubernetes or not? And I always said like, look, if it works for you, just do it, and if it doesn't, just don't. Right? And it goes for everything. It's just not for Kubernetes. So how we end up here? I mean, I have an edge. Like I was doing Java and stuff, and so how we end up from Java in Kubernetes, Java containers, cloud native. How we end up there? Good question. Let's try to answer this. So first thing that people usually don't understand with Kubernetes is an eventual consistent system, right? Eventual means something that is not now, is not always, and is not this. If you want to build a system that is now, always, and this, it is not an eventual consistent system. Like if you can read the cat joke, then that's basically Kubernetes in a cartoon for you. Okay, so we declare a state, and the cluster will try to converge, right? Like it will try to converge. Sometimes it doesn't, for these different reasons. So how do I explain Kubernetes to people? I usually define Kubernetes as an API. We have two contracts now. We have the application and the host, and that contract is called Docker. And we have the application and the rest of the infrastructure, and that is Kubernetes. APIs. Ha, fantastic. Kubernetes in three colors. Another different view of like, it is an API. Just get it ingrained, like Kubernetes is an API. Very complicated API. But the good thing is that it is not only an API to do what Kubernetes does, it's an API that allows us to define our own business. So we can extend this API and build our business. Like, hey. So I'm working in a bank now, and we're doing certain kind of APIs. I was working in a different startup before. We were doing different kind of APIs, but the foundation was Kubernetes. What is important about Kubernetes is that we can separate, and each concern of the application has an object that we can use to define my runtime, my configuration, my secrets, my routing, my monitoring, my authentication, my blah, blah, blah. You get the point. Why it's important? Because we standardize how we do certain things now. There's no discussion anymore about how we do configuration. We have an API for that. So I always talk about being above the API and being under the API. How we gone from Kubernetes being something very complicated that nobody wanted to use to this roaring success that we have with Kubernetes? Well, it's like we define very clear interfaces. Like this is three things. It's very, very simple. Like define clear interfaces, define primitives that make sense. The image does not make sense. That's why like what is this? I don't know. Don't ask me. Just like this. I cannot explain. Like and then simple implementations, right? Like then don't write something complex, because guess what? We trip, right? So maybe you don't know this. Kubernetes is built in something we call the controllers pattern. Everything that does things in Kubernetes is done through controllers. Awesome. What is a controller? I'll tell you later. What I'm going to do now is to give you an example of how to do things. And probably the best way of doing it is using state, because state is what people really like. And people want to put databases in Kubernetes. Don't ask me why they want to do that. Like, how do we start? Like, let's do payments and databases. Okay, yeah, that's the way to start. Fantastic. Why not? You know, you lose all the data and all your money. Hi. So how do you do it? You define YAMLs. Like Kubernetes is all YAMLs. People make jokes about YAMLs, right? Like this is how you define an application. And this is, I think it's an Nginx that has some kind of volume where we inject the website. Excellent. And then we have something called here. I forgot my thing. I forgot everything today because I had to be in the office too early, like 8. I mean, I have 3 children. I like just give me a break. So we have a few objects, right? We have the persistent volume claims, we have the stateful sets, we have volumes, we have lots of YAML for everything, and a lot of problems with indentation. But and storage classes. Hey, but why do we have all these complicated things? Why do we have all these objects? Why are we here doing all this YAML crap? Like, what is this? Provision. Okay. So let's see the example, right? Like above and under the API. We have an API that is Kubernetes, and then we have an application. My application is a stateful set, which means that it has a state. Okay. What does it mean? Then we need a volume, we need a disk, right? Like in the wall of reality. This is the fancy stuff. Like my application, this is the real world. This is where shit happens. I like my containers, my machine, my bash scripts, my stuff. Yeah, awesome. So the application defines stateful set here. Can you see the mouse? It's very small. Everything is small here. I was going to make a joke that. Anyway. So we have a stateful set there, and we have a persistent volume claim and a persistent volume. Hey, at the beginning, we don't have persistent volume claims. We just had pods and volumes, right? We have containers and volumes. Now we have an object in between to do certain things. Why do we have to do these things? Like, because infrastructure is hard, right? It is very different. It seems that it should not, but it's very different to mount a volume that is an EBS volume, that mount a volume that is a USB stick. Like, shocking, but hey, it's different. How we format and how we access. Like, for the application, it doesn't really matter, but for the people who have to put the EBS volumes or the USB sticks, it is important. So how do we do it? How do we go from this conceptual above the API wall to stuff that happens underneath? Well, we have something called the provisioner here, like the provisioner. And this is basically a controller. This is the piece of code that knows exactly what to do. So someone can go and write a storage class and define the provisioner that you want to use that is particularly specific for my disks, because my disks are white and very shiny and they need to be done in a particular way. And then we have all these parameters, etc., etc. Right? So we have a way of decomposing, like this thing that affects just to this kind of disk. We have an object for that. And we have a controller. We have a piece of code that we execute only when this disk is this type. Excellent. So in reality, what we have is this wall where we have YAMLs and bash. Everything runs in YAML and everything runs in bash. So how much YAML is too much YAML? It is too much YAML, right? But what happens is we end up in this wall that we end up with the operations and the development of the old wall, and then we have the API in between, and that API, who builds the API? Who is in charge of doing this, defining all these APIs? It's like that's what we call DevOps, right? Like, what is DevOps? The important thing is not that the name. The important thing is to understand that that API has a volume, has dimensions. Like you cannot have a white and black wall. You have to have the understanding that API has dimension. It has consistency, has density. we can talk for hours about philosophy, but yeah, let's keep moving. So why we end up in this world where we're separating all these concerns? We have deployments, we have replica sets, and we have pods. How we end up here, defining all these things? Like we have something called pod disruption budgets. Do you know what pod disruption budgets are? Yeah. It is something that people say like, why we don't have this information in the deployment is basically how we want to update the application, how we want to update my pods. And we have another object. Why? Because we wanted to maintain backwards compatibility and blah, blah, blah. It's about the API. Like it sometimes makes sense to create a new object and to modify a very used couple object, right? Different views because people look at things in different ways. That's what my wife said. So who am I? I'm Ivan. I'm from Barcelona. I'm disappointing human. This is a disappointing human because I did a talk in the Easter Meetup once dressed up as a dinosaur, and it was great. Yeah, it was great. But since then, everybody says that, oh, you're not a dinosaur anymore. So yeah. Dinosaurs are on the inside. I know. Yeah. So what else do? I collect typewriters by mistake, but I do. I have 11 now, I think. And I like fountain pens. So if you like fountain pens, it's very niche, but hey, we are very passionate. There is like there's people I know them. They're shy. Three. Typewriters. Anyone use typewriters? Okay. Well. I run meetups as well and complain about the weather because so my talk was going to be about what I learned running Kubernetes in production for the last few years, right? And I had this checklist and stuff, and then someone said, "Oh, this is very short." Okay, I will put more stuff. Okay. So yeah. Okay. First advice: who runs Kubernetes in premise? Not the cloud, on premise. Okay, this is for you. Upgrading Kubernetes for you in a slide. Boom. Look at this woman. Look at this. Like look at this one. Like this one is like, oh fuck. 4 years trying to find this slide. Anyway, what do you have to have if you want to go to production with Kubernetes? Make sure that you have all these things, especially ingress controllers and the SSL and the DNS sorted out, because the majority of issues always come from DNS and SSL. This is just like, wow. Then remember your Docker registry is where you are going to pull your images, so it makes sense to understand how these things work. Monitoring and logging, secrets management, user management. It is painful. So make sure that you know what you're getting into. And if you're using Helm, make sure you understand the Helm registry story and have one. And if you don't use Helm, come and talk to me. We need to talk. What you should have as well is image scanning. It is very important to know what you're running. Admission controllers. Mutating webhooks are like morphine. Use them with lots of care. Like Istio, it should be good, as we had to talk about Istio. I like the pattern of GitOps, really, because it reduces the vector attacks, the credentials. You don't have credentials spread across. It's the cluster goes out and reach out. That's much easier to manage than people have access to get into things. Right? Like you talk with security, they will say, yeah, out good, in not so good. I was going to make another joke that I will not make because, yeah. Then how to harden Kubernetes, make sure that you understand how to secure your API server and your network. Application checklist. Now, this is for your developers. They have to understand all these things. If they don't understand these things, there's lots of consultants here. If you cannot find any, come to my meetup next week. There are lots of them as well. Readiness check, liveness checks, telemetry, limits and requests. This is incredibly important. Like health checks and requests and limits are very important. One helps you to understand when your application or your containers are not healthy, when are they ready, when are not ready. The other ones helps with the scheduling. How quickly can you start a new pod? These things are important. Then security context, make sure that you use config maps and secrets. I like the pattern of owning the dependencies. So my application defines the services, the Kubernetes services that point to all the dependencies. So this means if my application is to talk to a database, my application will define a service that goes to the database. And we do this because now the DNS is in control of the application, not of the team that defines the database, and allow us to do things like, you went to this database, now I need to move it to the other cluster, and I just need to update this thing. I don't need to touch your application for anything. Helps with something that we call operability. HPA and PDBs, the horizontal pod autoscaler, and the pod disruption budget. This case status check is I gave a training about clusters, operators, and controllers, and I built this little application that basically allows you to define a status page just by defining. The application developer has to define a cron job that says how often you want to run a check, and we provide a dashboard and checks, and everything is really cool. If my VPN is working, I'll show you. Security. There's a lot of stuff to look at security. The best thing you can do is, well, this is a very quick list of the things that you should worry about, like protect the API server, check who's coming in, coming out, and what. Like this is like when you do a party at home, like you have to have someone at the gate, like making sure that not everybody gets into your party, and then someone looking after, like when I have a 16-year-old, when he wants to do a party with some friends, yeah, well. Watch what's running inside, literally. Oh, you can talk to control plane, who is usually around here, and they know a lot of security. How to manage a cluster. Things that you should do. Really good pattern. Expire your nodes every 24 hours. If your machines die every 24 hours, you can cycle your machines very quickly. You know that you can cycle your machines. And get into the habit of killing the classes very often, like 3 months, right? No upgrades, no patches. What you have to do is to modify the image that you're going to roll out and kill the machine, and a new machine will come and everything will be happy. We have operators to do this. At some point we will open source them or not, but you can write your own. Okay. GitOps, as I said, it's a really good way of controlling who has access to your cluster. There's a pattern that we've been working on called Cluster API. This is basically the idea of the cluster manage itself, right? And the expiration of the nodes and the upgrades things are very related with Cluster API. It's a very early project, but the pattern is very good. I'll always talk to my team and say, look, let's get the pattern right, and the implementation, we can get better at this. But if you get the pattern right, you get a lot done. Health operators are very important. One of the issues we have when we run in the cloud and you have systems like GKE or AKS or EKS is that these cloud services, they worry about providing you a cluster. They don't really care what is running in the cluster. However, for you, it is very important. If you don't know what you're doing, you will break your cluster. So how can we help developers with not much knowledge about Kubernetes to know if something is right or wrong? Well, we create an API, an abstraction, and we create this operator that helps to manage that situation. Eviction policies. If you don't define your eviction policies, someone else will do. This can be terrible if your kubectl or your DNS pod is evicted and you suddenly lose the ability to talk to pods in your machines. And labels, use labels, because tens and affinity, anti-affinity are critical. It says applications, health checks, again, readiness pro, it tells you when your application is ready. Liveness pro tells you if your application is okay. Requests and limits. Be mindful of the requests and the limits with the CPU. CPU throttles. If you start a Java process with very little CPU, it will work. It just works very slow. So, okay, look after your developers, right? And what we have is Git repos with templates, and we have the extensions. And then I'm going to show you. Like it's not working. I'm going to show you Octeto, which is something that is very simple, but it is it has changed my life, like the way that Docker did. Yeah. This is very small. Like, so wow, this is like really small. So this is a Flask application, a very simple Flask application. Like what I usually do when I write these kind of APIs is I will come here. Wow. Okay, so this is the application, right? I don't know where my mouse is. This is the application. What I usually do is this Docker run. I'm very good at not typing properly. Docker run, and then I mount a volume, put my code, and blah blah blah, right? So, which is good because I then run my application locally, and I can run a container with my application, my dependencies, and I don't have to have and pollute my machine, right? Who does these kind of things? Like, only come on, how do you do it? Okay, so I'll show you my cluster. I have a few things running here. Is the VPN on? Yes. So I have my application here. This one, boat, blah blah blah, right? I have an application running here. Okay, and what I want to do is to modify my application. I think that I can show you the application if it works. Let me see if this thing works. No. Okay, don't worry. I know what I have to do. Hey. So what I'm doing here is binding the port between my local machine and the pod in the cluster, right? Which when I click here, then it should show my application. Excellent. What's happening here? This application is running in my cluster. This is a pod running in default vault, blah blah blah. Yeah. What I'm going to do now is to modify my application. This code is in my local machine. I will put unicorns. And horses. I save the thing, go to my application, refresh. If I can hit it. Oh, I forgot. Nothing happens because I forgot to do something very important, which is showing you what I have to do. I do Octeto up. And what Octeto does is creating a cloud native development environment. Awesome. I don't know what that means. I do. And now I can come here and then click refresh. It's not working because something hates me. I'm going to blame the network. Yeah, something is not responding. Hold on. Let me see if this is the thing. No, this is wrong. Why? I just tried before and it worked. Now it doesn't work. Fuck. Okay, let's stop and start. It's because I cannot see what I'm doing. 8,000, yeah. Where is David? Like he did the demo on our last meetup and we had the same problem. Like, oh, it was working, and now when I will finish, I said, oh, I forgot to do something. Nothing works now. Well, I'll carry on and then see if I can do it. Okay, let's talk about the HA. So we define a pod now, like we're good, then boom, the pod dies, and then just like, damn. Okay, like hold on, I can replica 3. Now we're good. So look, you kill my pod. Hey, I still have 2 pods. I'm still good. Yeah, so let's see. I'm very happy. What happened? Someone kills my machine. Boom. Yeah, again. Like, okay, so what can we do now? We can define affinity and affinity rules and then distribute my pods, one in each machine, different nice sets. Like, yeah, we're good, we're good. What does it mean? Affinity and affinity rules. Bear in mind, remember what you're doing, required during scheduling, blah, blah. It means that you can have as many replicas as machines. If not, you can have more than 1 pod per machine. Remember that things will come and go, things will move, and you can end up in a situation that you don't want, right? So be aware of what your rules mean. Tense and toleration, the same thing. I will tell the scheduler that I prefer not to schedule blah, blah, blah. Okay. Like I will prohibit people not to run in this machine. Or actually, I'm going to kick everyone out. I'm going to run my things. Like these are the things that we can control with the tension and toleration, right? Awesome. You can define more things. You can define HPAs and PDBs and all these things and make things really good. And then you can define Istio and how you would do retries if something happens with your networking, and you can improve the availability, or you can define multi-cluster, or you can do, why not multi-cloud, right? Like something like this. Hey, does it work? Yes, on paper. It worked. So what's the future? What do we do from here? Like we have all these things, like, okay, what's next? Operators, of course, operators. So this is Flagger. It's an operator about doing canary deployments that the guys from WIF has done, and I think that they're announcing something today. If you go to Flagger app, you can see it. Doing canary deployments is not trivial because it depends on how you want to do your thing. You want to send this much traffic depending on blah, blah, blah. Operators, good. What is an operator? An operator is a way of offloading responsibility into a piece of code. So when we do this, we have different components. We have a CRD, which is basically in the whole wall is schema. My schema and my data, you can store data in a cluster. Fantastic. So now your cluster is your database. Awesome. We have controllers. And this is something that we do a lot in Kubernetes is watching the API server, and when we define certain rules, like actually I want to have 3 replicas, and if you see that you only have 2, then you call someone like, dude, get a new replica because we only have 2, right? I want to have cake in my table, and if like I don't have cake, someone bring me cake, right? Okay, so we have a controller that is basically doing something very simple. And then we have an operator that basically orchestrates. This is a machine state that defines logic. How do we do backups? Well, you have to do certain things when you want to do a backup, right? Like you want to create a dump, a database, and then we have to move these things. So you can define all these things as controllers, and then have an operator that is watching and orchestrates. Now that you finish doing this, call this other guy and do that, right? This is the operator. Now you will not get it right the first time. Don't worry. It takes time, and like this is something that you have to define. This is tightly coupled to your business, and it will take a while to get it right. But once you get it right, it's like magic. So yeah, how do you write an operator? You don't. Just try to avoid it. But if you really have to do it, remember that you have to have a feedback loop. You have to understand what's happening. You will not get all the edge cases, and they will bite you. Let's write tests and try to define properly what your business wants to do. Testing is really hard. We know, painful. Which operator is a little more painful? Now we talk Teto. If I can show you the demo, it will change your mind. Like wow. And another thing, like I was writing Java when I was very young, like servlets. Who remember writing servlets here? Yeah. So do you remember that moment in Java when they told us Do not put HTML inside of the servlet. Yeah. So do not put YAML or anything equivalent inside of the code. Do not write YAML inside of your controllers. Bad practice. Like, no, don't do it. It's like delegate. You use Helm. You can use something different to do that. Use GitHub. Use something like, do not create object definition inside of the controllers or the operators, please. I was like, wow, I'm done. I'm really good. Questions?
All right. Well, thank you.